Of course, we have to have my favorite student. Good old Anne. She gets everything right. Convert 60 meters per second to kilometers per hour. I remember it has something to do with a 3.6. Yes? Divider times. I'm going to show you a dumb way, Brisa, where if you forget and you don't have your green sheet handy, you can figure it out. So this is what I do, I kid you not, every time, because I don't have a green sheet handy. I have, over the years, memorized that 3.6 has something to do with it. 100 kilometers per hour is freeway speed, and I've done on the freeway often enough, and 100 is a nice number to work with. So here's what I say to myself, Ira, every time. I say, okay, 100 kilometers per hour, do I times or divide by 3.6? If I times by 3.6, see, I can do that in my head. 100 times 3.6 is 360. That would mean that 100 kilometers per hour was the same as 360 meters per second. That would mean on the freeway, I'm going past 3.5 football fields every second. I don't think I am. I've been on the freeway. I'm not going past 3.5 football fields every second. You know what? It isn't times. It's the opposite of times. What's the opposite of times? If you're looking for a stupid way to remember it, Zach, every time, if you ever see me doing a conversion, I'm on the freeway, I'm saying 100 kilometers per hour times 3. No, it's not times. That's way too fast. It's got to be divided. And it's 100. It's a nice number I can do math with. Or you can memorize, but I've never bothered. I learned the 3.6, and that was Kiana as far as my brain was willing to go. So it's going to be from meters per second to kilometers per hour. It's going to be times by 3.6. Well, 60 times 3 would be 180. 60 times 0.6 would be 36. 180 plus 30, 216? I can do math in my head. 1 mark, I would take a half mark off if you didn't have units. Convert 108 kilometers per hour to meters per second. I think to go from kilometers per hour to meters per second, it was divide by 3.6. I'll bet you this probably works out even. Dividing by 3.6 is the same as dividing by 6, dividing by 6, and then moving a decimal. Dividing by 6 is going to be 16. Doesn't work out. Does it work out evenly? 108 divided by 3.6, 30? Okay. Meters per second. By the way, before I go further, technically, how many sig figs should I have gone to here? 1, which is why I'm kind of ignoring sig figs for the rest of this year. But yeah, 1. Technically, here I should go to 3, so it should be 30.0, whatever. I'm not going to be that fussy. 1 mark each. Now we're doing some equations. I'm going to show you the full DFIC method that I encourage you to go with until you get really good. So how far? It wants me to find that. 18 is a speed. 24 is a time. I do have an equation. It's D equals VT, so it's going to be 18 times 24. I should be able to do that in my head. 18 times 25 would be 450, so it's going to be 432? Yes. I can do math in my head. Units. 432 what? Meters. Now, I did a quick check as I was writing down my 18 and my 24. I noticed the 18 was in meters per second and the time was in seconds, so I don't have to do any conversions. But that is always, Sasha, a habit I get into as I'm writing down my data. I'm double checking, do my units all match, or I'm going to do some conversions. You get 2 marks if you got the right answer. Otherwise, I would give you 1 mark if I saw the equation, half mark for the numbers, and a half mark for the answer. What that really means is even if you don't know what to do, if you know what equation you were supposed to use, you can pass the question. Number 4, what are they asking me to find when they say how long? How long could mean a length, how long. It could mean a time, how much time. So what do they want me to find here, a length or a time? I'm going to go T equals question mark. I guess that 4,500 is a distance, and it's in meters, and that speed, that 25 is a speed, and it's in meters per second. So Rick, my units match. I need an equation for time. That one I didn't put on your green sheet. However, I did put this one on your green formula sheet. I want to get the T by itself. How would I get the T by itself? I need to move that V over. How would I move that V over? What's the V doing to the T? So how will I move it over? So are you telling me that That's the same equation? It is. It turns out I can go T equals D over V. It's going to be 4,500 divided by 25. I should be able to do that in my head as well. 180 units. It's time, seconds. If you wrote that down, you get 2 out of 2. Otherwise, I would give you 1 whole mark if I saw that, half mark for that, and a half mark for the answer. If you skip some of those steps, I will give you full marks, but trust me, it'll come back to bite you as the questions get more difficult. There is a minimum amount you should do. I encourage you to. Zach, how many marks was question 4 worth? How many marks was question 3 worth? Question 3 is worth how many marks? 2. How many marks is question 4 worth? How many marks is question 5 worth? Probably means there's an extra step, or there's a curveball, or something. And I will try and give you hints like that even in my marking scheme. In other words, if you've just done a couple of 2-mark questions and you run to a 3-marker, probably means you're going to find something in order to find something. 2 steps. If it's a 4-marker, probably means you're going to find something in order to find something in order to find something. Well, I said to myself, self, they want me to find how far. They gave me a speed. They gave me a time. I said, oh, this seems really easy. D equals VT. It's going to be 330 times 6. Geez, Duick, this isn't tough at all. It's going to be 100. I should be able to do that in my head, but I'm wearing a pirate costume, so I'm dumber. 1980. Mr. Duick, why is that worth 3 marks? Because this is wrong. Why, Matt?
Because it took 6 seconds for your voice to go the mountain and come back.
So I need to take this distance and do what?
Well, you have to divide 6 by 2.
Or I could divide my answer by 2, but somewhere along the way, I have to divide by
2.
If you have 1980, that gets you 2 out of 3. 1980 divided by 2, well, 2,000 divided by 2 would be 1,000. 1980 divided by 2 is going to be 960? No? 990, that's what I said, 990. You guys, it's, you know what, it's my pirate accent. You can't understand me properly. 990 units, meters. Okay. By the way, if you are ever at an echo, 990 is really, really close to what nice round number? 1,000. If you're ever at an echo, every 6 seconds is a kilometer away. Do you need to know that? No. Is it kind of cool to be somewhere and have a rough idea of how far away the mountain you're bouncing off of? It adds to the echo effect, I'm telling you. So I would give you 1 mark, half mark for the numbers. I would give you a half mark if you stop there, and then 1 mark for dividing by 2. How many of you got that? Nice. Good. Based on this graph, how fast is this object traveling? What kind of a graph is this? Distance versus time. Oh, it's going to be the slope. So here I went slope equals rise 7.5 minus 5 over run 9 minus 3. Is this a fraction? Yeah. Is there more than one thing on the top? Then I'm going to put it in brackets on my good calculator. Divided by, is there more than one number on the bottom? I'm going to put it in brackets. By the way, you could do the top and then do the bottom and then, but for Pete's sakes, I'm lazy. I got a good calculator. I got 4.16666. Sorry, 4 point. I said 0.416666. I'm going to write 0.42. I didn't tell you how many sig figs to go to, so if you went to 1 sig fig and you said 0.4, I guess I'd take that, but that's rounding off a bit much. I would argue probably I should consider going to 2. No, that's 1 sig fig. You know what? I'm going to go 0.42 meters per second. If you went 0.416 repeating, I'd give you that. If you went 0.41, that's rounding off bad. I'm taking a half mark off. That's not a 1 if you stop there. What's next to it? It's going to become a 2. Okay? 1 mark. What's the proper equation of this line? So for 2 marks, if you said 0.42t plus 4.5, that gets you 2 marks. I would give you 1 for this and 1 for that. Did anybody actually calculate what the proper y-intercept should be? Okay, so let me do that. The proper y-intercept would be y equals mx plus b. Let's use 5 equals 0.42 times 3 plus b. So it's going to be 5 minus 0.42 times 3. Correct y-intercept is 3.75. So for a bonus mark, if you went d equals 0.42t plus 3.75, that will get you 3 whole marks. Yes? I'll take that. I'm just not really fond of y and x anymore. Now, if you got this wrong, but you dropped it down there, I will give you the 1 mark because that was your slope, whatever you calculated, and you knew enough to say that goes in front of the t variable. I'll give you 1 mark for that. Okay? Any questions or lawyering with me? Now is the time. Otherwise, if you can give yourself a lovely score at the top out of 12. Yes?
For B, I got 3.72.
3.72 because you used a rounded off value. I'll give you that, but you know what? You'll notice I used my answer button. Why would I use a rounded off value when I had a teacher who went on a good rant about getting a half-decent calculator, which, among other things, if you got a half-decent calculator, I guarantee has an answer button, which is less typing and more accurate. That's like twice the win. Just saying. Learn to use where you're going to see all the time I use my answer button. Find where yours is. It's on there somewhere. Say, I'll take that, but I'll also frown at you and say, did more work than they need to for less accuracy. Any other questions or lawyering with me? If you would please make sure your name is on them. If you would please make sure your name is on them. Pass them inwards. The person in the middle is going to put them in a nice, neat stack, all facing the same way. So what you can work on for the remainder of class, and I will help you, as will my trusty assistant, Rylan, is this concept of instantaneous velocity. So if you can get out lesson 3, please, from last day. Nick, did I give you lesson 3? Yeah. Okay. So I want to talk a little bit about number 1. I did attach the answers. Remember, your answers, especially when you're laying your ruler down to find a slope, might be a bit off because I might have laid my ruler down at a slightly different angle. So if my answer says 13 and Ira, you get 15, I'm probably fine with that. But if you get 3, probably not. Okay, I really wanted to talk about this first one. So this is distance versus time for a walk. It says, number 1, describe the walk in words. Really what I want you to tell me is when you're going forwards and backwards and where you think you're speeding up, slowing down, or stopped. So at T0, start out going forwards. Hey, for the first section of the walk, are we speeding up or slowing down or at a constant speed? And how can you tell?
Speeding up.
Speeding up? Why?
Because it's descent.
Okay. When do I stop speeding up? At what time?
10 seconds-ish.
Yeah, I would take 9 seconds or 10 seconds. So that I would say sped up for around the first 8 seconds going forwards and then started to slow down. Like that's what I'm looking for in describe. If I gave this to you on a test, what I would do is I would put certain letters in certain locations and I would say, what's happening between those 2 letters? What's happening between those 2 intervals? What's happening between those 2 intervals? Okay? Number 2 says find the average velocity for the entire trip. Find the average velocity for the time interval from 0 to 11 seconds. Find the instantaneous. So number 4 is where you're going to start to lay your ruler down and find the instantaneous velocity. Then, turn the page. Number 5, here we have distance versus time for a dog walking. Looks like the dog was walking forwards for a while and then started walking backwards. Okay, total distance, total displacement, average speed, average velocity. You can use the equations. And then I want you to find for number 10 the instantaneous velocity at certain times. Then number 13, here's a graph, a distance versus time graph. I said use the graph to answer the following questions. Many of your answers will be approximate. At what time is the instantaneous velocity 0? Describe the motion of the object between each of the times in part 2, whether you're speeding up, slowing down, going forwards, going backwards. What's the instantaneous velocity at 10 seconds? And you can answer those questions there. Okay? You have all class to work on this. I'm not going to throw something new at you because apparently you guys don't want homework tonight or something like that. You got something you're wandering the streets at night like little hooligans or I don't know. So I guess I'll let you trick or treat.